Hey everybody! Today we are going to prove that the logarithm of a product is equal to the sum of the logarithms. That's the general idea we're proving today. You'll see exactly how this kind of boils down into a common logarithm property that you definitely have seen before. But before we do that, let's just actually begin proving it basically. So what we're going to do here is kind of recognize, okay, we're doing stuff related to integers because we're going from 1 to 2 to 3 all the way to n for any general n. And so whenever we have products and sums and integers involved, it's probably a good idea to use induction. And so that's what we're going to do today. So let's start with the base case. So the base case here, we're going to use we'll just start with n equals 1 because that just seems reasonable. And obviously we didn't have to start at 1 here, it's just common to do it. And then once we prove it starting at I equals 1, then we can kind of move to more general cases and stuff. But for now, this is all we need. So the base case here is where n equals 1. And so then what we get is the logarithm of a product from I equals 1 to 1 of a sub I, okay? And so whenever we do that, whenever we have a product of one thing, it's just one thing. So this is simply just log of a sub 1, okay? And that's it. We're just multiplying the first thing, and that's it. That's all we're doing. We're not multiplying it by anything. So this then becomes, well, we can think of this, again, kind of backwards, as the sum from 1 to 1 of log of a sub I, because here we have like the logarithm of one thing, right, because we're just doing one thing there, and so that's it. So there we go, that's pretty easy. I also want to show n equals 2 just because that might be a little bit too trivial. I know generally we have trivial base cases, but that might be a little too much. So let's just look at n equals 2, and then we recognize that we have log of the product, so from 1 to 2 of a sub I. And so what this is we're multiplying two things: the log of a sub 1 times a sub 2, essentially. So we're taking we are taking the log of a sub 1 times a sub 2, right? Just these two things. And then we know that this is the common logarithm property that I'm sure you've seen in like high school or college or something. And that's just simply the fact that this is equal to log of a sub 1 plus log of a sub 2. Sure, you can't necessarily just jump from that to that. There is like, I don't think it's really a definition, but there is like a proof of that, kind of depending on the whole exponent thing. It's kind of complicated, so I'm just going to take this for granted, but you can prove it. If you want, I'll leave that as an exercise to you. I just don't want to. But yeah, so from here we can just go and say that this is the sum from I equals 1 to 2 of log of a sub I. And that's pretty easy, just to see it's this one plus that one, so it's a sum from the first one to the second one, and that's it. So this is our base case with an additional base case, just to make sure that we have it down. Okay, so now we'll move to the induction step where we actually prove it for a more general number. Okay, so now we're doing induction here, and so we're assuming that the claim works for n equals k, so if we just plug in a natural number k in there for n, same thing basically, so we're going to assume that. And now we're going to prove that it works for n equals k plus 1. So essentially just the next integer. So we can just start with that. We'll start again just on the left, just because why not. So we'll get the logarithm of the same product, but we're ending it. So we're starting at 1 and ending it at k plus 1 of a sub I. Okay. And so then from here, what we can do is kind of split up the product. We can think of this as the logarithm of, we'll have the product here from I equals 1 to k of a sub I, okay? So that's just the first k terms. We're missing that last k plus 1 term, so what we can do is simply just multiply it here. So a sub k plus 1. This is not part of the product, sorry if that's a little confusing, but this is the product, and then we're multiplying that by a sub k plus 1, and in total, this gives us this, the sum from 1 to k plus 1. I hope you can see that. And so then we can apply the rule that we stated earlier for the case of two things being multiplied, and just basically say, okay, well, this is going to be the log of the sum from I equals 1 to k of a sub I, and then we're going to be adding that to the log of a sub k plus 1, right? So basically we're multiplying two things, and so I'm splitting them up into the addition right there. And so then from here, what we can do is remember that, so I'm just going to put it all down here. Remember that we said that the log of a product, so remember, assuming the claim works for n equals k, then we can just simply put this into this, which is the only difference being n equals k. So what we have here is the sum from I equals 1 to k of this thing. So log of a sub I, and then we're going to add that to the last term, log of a sub k plus 1. And then our last step here is to just add them all together, kind of the reverse of what we did earlier. So I equals 1 to k plus 1 of log of a sub I, because this is just that k plus 1th term, and we're just adding it to the end of there. And so yeah, we proved the whole claim here. So we did the base case and the induction. So I hope you enjoyed the video. Thanks for watching, and I'll see you later. Bye.